the product rule. So if f of x equal to the product of u and v, so u times v, then f prime of x, the derivative of x is u times v prime plus v times u prime. And this is another way of writing the same thing, but using the dy dx notation. So let's look at an example how we can use product rule. So different from the previous lesson, where when we have like a product of a binomial, so what we did before by simply using a power rule, we actually multiply this out by doing a FOIL, expand it out, and using power rule, right? That was yesterday or last week. But now we're looking at, well, if we use the rule, right? So we don't have to go through it like this, where we actually expand it out and then we take the derivative using the power rule. By using the product rule might be slightly easier. So if you look at it, okay, so the rule is saying basically it's one of the binomial times the derivative of the other and plus the vice versa. Then you take keep the second one and times the derivative of the first. So if you take a look, I'm going to take the derivative of the first item first, okay, first term. So using power rule, okay, so 4 times 9 is 36x cubed plus 4 times the second term plus the first term times the derivative of the second term. So that simply becomes 3x squared minus 10x. Now, if you expand this out, you will get the same answer. Okay. Now let's look at another example. If y equal to parentheses radical x plus 4 times cubic root of x times parentheses x to the 5th power minus 11 to the x to the 8th power. Now, if you want to FOIL this out, it could get quite messy. So this is where product rule will come in handy. So once again, now one of the best way to do before you do power, just like the power rule, anything radical would be nice to change them into rational exponents. So this is equivalent to x to the 1/2 power, and this is equivalent to x to the 1/3 power, which is cubic root. Okay, then from here we're gonna take the derivative of the first term, which is 1/2 x to the negative 1/2 power, plus 1/3 times 4, so we have 4/3 times x to the negative 2/3 power times the second term. Then plus the first term times the derivative of the second term, which is the derivative of the second time this time. So 5x to the 4th minus 88x to the 7th power. Then all it's left really is using algebra to make it look a little nicer, or where we generally don't like to um, leave our exponent negatives, okay, or even radicals, okay. So we just change them back to the radical notations, okay. Now the second rule we're going to learn is the quotient rule. Okay, so if we have the product rule, we have the quotient rule. So if f of x equal to u divided by v, then the derivative of x equal to v squared on the bottom in the denominator, and then on top is the first term, derivative of the first term times the, or derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. Okay, so let's take a look how we're going to use this. So you have a fraction, okay, a quotient. So according to the quotient rule, when we take the derivative, we're going to take the denominator, square that. That's what goes on the bottom. Then we take the derivative of the numerator times the bottom, the denominator, minus the numerator times the derivative of the denominator. So this is where you see. So basically, you're taking the derivative first. Sometimes they say, well, derivative of the top times the bottom minus the top times the derivative of the bottom. Okay, you see a lot of people saying that. Might be easier to remember. Okay, now let's do another example. So here's another quotient. So the derivative is the bottom square times the derivative of the top times the bottom minus the top times the derivative of the bottom. Then, of course, after you're done, you just do the distributive property. You combine like terms, modify it. Not modify it, simplify it. So that's what you end up with. So the derivative of this 3x plus 5 over 5x minus 3 is negative 34 over 5x minus 3 squared. Now, one of the big thing, okay, we're going to be talking about is what we call the chain rule. Okay, so this is a formal definition of a chain rule. It looks complicated, right? So y equal to f of g of x, then y prime, the derivative equal to excuse me, df of g of x divided by d of g times dg dx. So a lot of time the way I like to tell my student is, okay, take a look at this function here. Now, I know we can use power rule, but imagine this. You're going to expand this, you're going to take this binomial and you can multiply itself 5 times. That's a lot to start with, right? So this is where chain rule comes in very, very handy. So the chain rule says, okay, we're going to treat this whole thing inside this parentheses as a big O X, right? So if this was just x to the fifth power, then what happens? Then the answer would just be 5x to the fourth power, right? When you take the derivative. But since inside is not x, if inside was x, the derivative of x just become 1, so you don't notice anything. But since inside the parentheses, inside this function here, it's not just simply x, it's 5x cubed plus 3x. So the chain rule says you take the derivative, then you multiply what's in, then you multiply the derivative of what's inside. Then you take the derivative of this again. So 3 times 5, you get 15x squared plus 3. So that's how chain rule works. So you use the power rule, and then you multiply the derivative of what's inside. Same thing here. You can see this also applies right here with a radical. So again, you want to think a radical is to the 1/2 power. Then we just do the power rule. So we're going to move the 1/2 to the front, and you have the what's inside here, and then this becomes negative 1/2 power. Then don't forget the chain rule. You're going to take a derivative of what's inside. So what's inside here is 3x squared minus 4. Then rest of it is just simplify and then to make it look better. Okay, especially when we have a negative 1/2 power, that just means what? Radical, but in the denominator. Okay, so now this is where we combine rules together. Okay, so if you look at this last example here, you have y equal to, you have a quotient here to the fifth power. So apply the power rule first. The power rule goes 5 to the front of what's inside to the fourth power. Then take the derivative of what's inside. The derivative of what's inside is a quotient. Then we apply the quotient rule, what we learned before, to the second part of this answer. So we're going to multiply. Now we're going to take the bottom square, then the top is going to be the top, derivative of the top times the bottom minus the top times derivative of the bottom.